Good morning, everyone. My name is Scott McBrien. I work for Red Hat as a curriculum manager for Red Hat training. If you are asking questions in Q&A, you'll be speaking with Vander Bassenkool, who is one of my coworkers. Both of us worked on the RH436 Red Hat High Availability and Storage course, which this presentation is pulled from. All right, so let's go ahead and begin. I've shared my desktop, so if you look at the desktop sharing portion of the WebEx UI, you'll be able to see exactly what I'm showing you. I have the presentation there as well, and I'll be advancing the presentation through the desktop share. All right, so we did some introductions. I work for Red Hat. I work for Red Hat training. I've had experience as a Red Hat consultant in a variety of other places as well. This is not my first go-around with Cluster Suite. I've worked on it for quite some time. And we've recently been working on an update for the RH436 that will include Red Hat Enterprise Linux 6. All right, so one of the core components of Red Hat Cluster Suite is Conga. Conga is really a couple of different tools together. One that lives on the cluster node, the other one that lives on a machine that presents a web interface. So I've already taken care of doing a lot of the infrastructure stuff that has to happen with putting together a cluster. And we're going to review that in the next few slides, and I'll show you what I've done to set that up. We have to do all that work in order to stage a highly available service. All right, so I've got this web browser open, and I'm going to connect to the machine that I have running the Lucy daemon, which is part of the Conga suite. So this snazzy web interface is being presented by Lucy, which is part of the Conga suite. So let me go ahead and log into it here. And from here we can define new clusters, we can manipulate our existing cluster, and I've got a cluster created called temp cluster 1. So we'll talk a little bit about this in the next coming pages. All right, also, I've got a couple of SSH sessions open to my different nodes. So node 1, 2, and 3 are the nodes that belong to this cluster, temp cluster 1. And if I run the command cluestat on any of them, what I'll get is a report of the nodes that are online or offline, whether we're core as a cluster or not. And we'll talk a little bit about quorum in the next pages or so. So all these guys should have the same view of who's in the cluster and kind of what's going on. Now, right now, I don't have any services running in the cluster. Services would also be displayed in this tool, but because there are none yet, we don't see them. All right, these three nodes, nodes 1, 2, and 3, they're all running the Ricky daemon that's part of the Conga suite. So when I installed the cluster, one of the steps is to go ahead and use yum to install Lucy on one machine that's going to present this nice web-based interface, and then install Ricky on all the working nodes, the ones that are actually going to be tied together and worked with as a cluster. All right, so if we wanted to create a new cluster with Conga, we could go to Manage Clusters in the Lucy interface, and we hit Create, and we fill out a form. And when we click Create the cluster down at the bottom, what it's going to do is install packages on the Ricky-enabled nodes that we've identified here in the node name portion. So let me just sketch one out here. So we're going to create a cluster called Fluffy. You put in your nodes, and the password for the Ricky daemon on all the nodes. And you can, if you select the Use Same Password for all nodes, it would auto-populate the password field as you're adding new nodes. Or you can individually type them if you can't guarantee that they're all identical. Locally installed packages, this radio button here says that I've already installed a bunch of software that goes with running a cluster. If you select instead download packages, it'll use the high availability add-on to pull down packages using yum and install them on the machine as necessary. Reboot the nodes before joining the cluster. So after they finish their package install, they'll actually reboot, and when they come back up, they'll be a part of the cluster. And enable shared storage support. So this makes sure that they can do things like iSCSI and a few other shared storage technologies. All right, so I've already done this. This is actually how I created the temp cluster 1 cluster. I put in the name. I typed in all of my nodes, node 1, 2, and 3. I told it to download the packages, reboot the nodes before joining the cluster, and they come up. All right, so this is what it looks like when you're done. So there are my nodes that are members of the cluster. We get a little bit of information like their uptime, their state. Here's their votes that we use for determining quorum. We'll talk about quorum in a minute as well. So it's fairly straightforward. Now what this was really doing was the Lucy web interface was creating a XML-based configuration file, which was then sent to all of the nodes with all the data. So out here on one of our nodes in Etsy cluster.conf, this XML-based configuration file was what was being created. So we got our cluster definition, and then we have a section for our cluster nodes, and here's a piece for all of our different nodes, node 1, 2, and 3. And just adding the cluster, that's pretty much what you get. All right, we'll talk a little bit more about the content of that file and some of the other command line tools that we can use a little bit later in the presentation. All right, but there's still more stuff that we have to do before we can deploy a service in Red Hat Cluster Suite. So after we have the cluster defined, one of the things that we need to set up is a fencing mechanism for handling damaged or not properly operating nodes. So notice over here in the Lucy interface, we have under our cluster modification the ability to check on fence devices. And I've already created a fence device called KVM Fence. Now it turns out that my 3 nodes, nodes 1, 2, and 3, are all virtual machines running on the same hypervisor. So this device, KVM Fence, is really going to make a libvirt call on the hypervisor and tell it to reboot one of the affected machines. So if there's some discrepancy between the cluster's overall view of what's going on and a single node's view of what's going on, or there's some detected failure in a node, the other members of the cluster are going to make a fence request of their hypervisor, and it's going to kill off that damaged or misbehaving node. So you have to have a way of destroying or removing nodes from the cluster, and that's fencing. Now, there are a whole bunch of different fence devices that are available. I'm using this one because I'm using virtual machines on the same hypervisor, which allows me to make calls to the hypervisor to fence them away. But if you have a APC power supply, you can make an SSH connection and turn off different ports on the power strip. There's a fence mechanism for that. If there is, I'm trying to think of some other mechanisms, less reliable, I guess, is SCSI fencing. So you can tell it to, get rid of its shared storage that the machine has access to by messing around with its SCSI controller. So you know what? Let me go into the ad here. So you can see that there's a ton of different fence devices. There's DRAC, ILO, so you can connect to their out-of-band management interface to control the working of the machine. There's VMware fencing, Blade Center fencing for IBM. The one that I'm using is this FenceVirt multicast mode. That's what my device is. All right, now if I take a quick look at it, so after you define the fence device, you then go in and add it to your different cluster nodes. And these are all the nodes down here that we have currently using this fence device. So if I go back over to the nodes view and I click on a specific node, one of the things that I've added to it is a fence device. So after the cluster was created, I created my fence device. Then I went in here to each of the individual nodes, clicked Add Fence Method. I named the method. And then once it shows up on the node, I can add a fence device or a fence instance to it. So based off of what you've defined under fencing devices, you can choose it, and then it'll change what's required in order to activate it. All right, let me get rid of that. Okay, now again, what this web interface is doing is it's building the XML-based configuration file and then sending that to all the nodes that are members of our cluster. So if we take a look at our cluster.conf out here on one of our nodes, this fence section, when I go into each individual node and I add my fence device to the node, it's what adds this fence section to the cluster node definition in this XML configuration file. And so we can see that I've just added the same fence device, KVM fence, to each of the different nodes, but one thing that's different about them is the domain that gets fenced. So I said that for my fence device, that we're making a request to the hypervisor that's running all these virtual machines to tell it to reboot a specific node. So we have to tell it the virtual machine name or the virtual machine's ID in KVM to identify what node should be managed. So when we make our call for this node, we're going to tell the hypervisor, reboot a machine named node 2. Down here, reboot a machine named node 3. All right, so that's not the end of the infrastructure that we have to have first before we set up a highly available service. We're also going to have to tie together a bunch of different resources to make our highly available service. So we're getting to the point now where we're ready to start defining our service. Now for our webinar example, we're going to be using a web server as our service. So there are a couple of things that we're going to need in order to get a web server going. So one thing that we're going to need is the software that goes with it. So I'm going to go over to the Resources tab, and I'm going to add some new resources. So there's a bunch of different supported resources types, and one of them is the service that we're running. So I'm going to add a Apache resource type, and we give it a name. This is going to show up later when we assemble all these resources together into our service. We can provide some options, and then this is when we're shutting down Apache. How long should we wait in seconds before we actually issue the shutdown? All right, so I'm going to say it should be a shutdown wait of 3 seconds. All right, but we need more resources than just this. I'm going to add another resource. Another resource that I'm going to add is an IP address. So when our service starts up, we're going to assign a floating IP address to whatever node is managing the service. We're going to start up the Apache daemon on whatever node is managing the service. And the third thing that we're going to need is the data that should actually go with it. So I'm going to be creating another resource in just a minute. So our IP address that we're going to use that's going to be the floater is this. And this is kind of unique to my environment. I'm using the same lab setup as we use in the class that this presentation is pulled from. Yeah, that's fine. All right, the third resource that I'm going to define for this service is the data for it. So when Apache is running, it's serving files out of var www HTML by default, and I want to make sure that all of the nodes get the same web data. Now, what I've done to present that is over here on my nodes is I've set up an iSCSI target that I've partitioned, and I've created an ext4 file system on that partition. So this partition is, or this iSCSI device is being presented through multipathing. I've got my disk partitioned up. So here's my partition that's about 130 megs in size. Right? I don't need a lot for this demonstration. And then I've already formatted it as an ext4. And I've put an index HTML file there. All right, so if I do a mount, all right, he's already been formatted. I've already put some data there. Well, I want this partition, which is currently shared to all the nodes in my cluster, to be mounted under var www.html whenever one of the nodes starts up this Apache Web Service, to make sure that they're all serving the same data and that they all have access to the same content. All right, so let me unmount it here from my node. And I'm going to go over, I'm going to add a file system resource. When we mount this file system resource, we're going to put it at var www.html. The device that we want to make sure is mounted is dev mapper cluster storage P1, right? The partition on my shared multipathed iSCSI target. I'll make sure that if we try to unmount it and it doesn't work for some reason, we'll just reboot the host node. That way we ensure that the host node has released its control and it's not trying to write files or do anything wacky to this device while somebody else is trying to start up this service. All right, so we've got our resources. All right, but there's one or two more things that we need before we can tie these together into a service. One is a failover domain. So this is something that when we define the service, it's going to ask us what failover domain to use as part of the service definition. So we need to have one defined before we start our service definition. So I've made this failover domain called prefer node 1. It's a prioritized failover domain, which means that we can assign weights to the different nodes to decide who should start the service when it gets failed. And so down here at the bottom, when I've added the different members of my cluster, notice that there's a priority field. A lower number priority is better. Right, so if node 1 is out there and available, then it's going to be the one that whatever service is classified as prefer node 1 as its failover domain, that service is going to run on node 1 if it can. Nodes 2 and 3 I set with the same priority, so if node 1 is unavailable, then the RG Manager service, which handles the services, is going to assign a service to run on either node 2 or node 3, and there are a variety of factors that make that decision for us. How many services are running on either of the nodes and a bunch of other things. So I've made the same priority, which says basically RG Manager you can pick. If I wanted to, I could set a specific priority. All right, also with this failover domain, notice that I do not have no failback checked. That's kind of important because when I define my service and I actually set it as a prefer node 1 failover domain, when I kill off node 1 where the service is going to run, it's going to move to either node 2 or 3, right? We expect that. But if node 1 comes back from its fencing operation and rejoins the cluster, then that service is going to migrate back to node 1 because node 1 is the preferred for this service. So if you didn't want that failback operation to occur, you check the checkbox. All right, restricted lets you specify which nodes a service should be run on. So even though it might be running in this entire cluster, I could say, well, really, this service should only ever run on node 1 or 3. So unlike priority, we can actually carve out and only run the service on a portion of the nodes in our cluster. All right, so I've gotten all of my things lined up, all of my requirements lined up. Oh, we've already talked about failover domain. We've already defined some resources. Now it's time to actually tie it together and make a service. So I've gone into the Lucy interface here into the Service Groups tab, and I'm going to add a new service. I'm going to name the service. I'm going to start the service automatically when it gets defined. I'm going to use my failover domain that I've defined earlier. So the service should be running on node 1, and if node 1 is ever taken away or has a failure, we're going to expect it to go to nodes 2 or 3. But if node 1 comes back into the mix, we expect it to migrate back to node 1. The recovery policy is relocate. So relocate means we need to, when we sense that there's been a failure on a node that the service is running on, we need to move it to another node. All right, restart is we're going to start the service fresh on another node, and disable means we're just going to turn the service off if there's a failure. All right. So here is my service. We're missing some stuff. So I define a name of the service, and I put in some architecture of like its failover domain and some things that should happen when there's a failover. But I'm missing all of the resources that make the service actually a service. So there's this little Add Resource button down here, and we can select from our already defined resource types. So I'm going to say that when this service starts, I need to assign the file system to it. All right, so I add this to my service. It says that when the service starts, we're going to go out and we're going to grab dev mapper cluster storage P1 device. We're going to mount it at var www.html, and that's where all of our data that's associated with the service is going to come from. All right, I'm going to add another resource. We need our floating IP address. When this service starts, we have to take this floating IP address and assign it to the node that's responsible for the service so that we can actually receive connections going to this service. All right, the last thing I need is Apache. Right, when the service gets started, we need to start up the Apache daemon, and here's the configuration stuff that goes with that Apache daemon, so that we can actually receive requests on that IP address, and it goes to the right port, and the service responds and grabs data from that device and shares it back again. All right, now when you're defining these services, there was a button labeled Add Resource, and then for each resource, there was an Add a Child Resource button. So I just added all of mine individually. But if there's a relationship between the different resources that have to be added, like we want to make sure that the file system gets added first, and only after the file system has been added will we then do the IP address, and only after the IP address has been added would we then do the Apache service. That's what the child-parent relationship is for resources. So it allows us to nest resources together, and if there's a failure in controlling one of the resources, it will fail the service, and it hasn't done any of the other resources that were added as children of that resource. So this is how we can set up a hierarchical relationship between resources that need to be added to our cluster. All right, so now that I've submitted all of my resources, we should start up the Webby service automatically, because that was one of the items that I set up right here. Automatically start the service. And if I go over to one of my nodes and run cluestat, All right, down here at the bottom, we get a list of all of our services that are being controlled by this cluster. And we can see that the Webby service is being offered by Node 1. Now what that means is that we can open up a tab here. And we'll go to the IP address. And here is the web page that's in that index.html file on the shared storage. All right, over here on Node 1, oh, and he puts it somewhere else. How about we go to Node 2? All right, this is the file that we're being shown from Node 1. Right, we have the hello from cluster 1 scrolling across the top of the screen, and then the this is the most annoying page ever banner underneath of it. All right, so now we're running our service. Right, we can see that it's working. Actually, I also have a, I think I have a host name for this as well in DNS. There we go. So we'll use this host name instead. All right, no problems. But what happens when our node goes down? All right, well, what we're going to expect is that the service gets failed over to one of the other nodes running in our cluster. So this tab right here, this machine named Desktop 1, this is the hypervisor for all these virtual machines. And what I'm going to do is I'm going to blow up Node 1. I'm just going to kill it. Bam. So when I try to access the page, the little web browser is spinning, and we're waiting to access the page. And if we go over to one of the other healthy nodes, we can see that the service was migrated to one of the other nodes. So when I'm accessing the floating IP address, this floating IP address and all the pages that are associated with it through Apache are now being served from Node 3. All right, if we look at Node 3, there we go. You can see that he's got this floating IP address assigned to his network interface. All right, so when there was a problem with Node 1, it got fenced from the cluster, which caused the service that was running on Node 1 to be migrated to one of the other two healthy nodes in our cluster, and everything's cool. All right, Node 1 is actually dead. Right here I am trying to do something to it, and it's not responding. And if I do a verse list all, right, you can see Node 1 is not running. All right, so let's boot it back up again. Yeah. All right, and when he comes back up, I'll SSH back into him. Over here, I'm going to run a cluestat through watch. If you've not seen watch before, it basically just reruns the same command every few seconds. I told it to run every 1 second. So here's it running cluestat. Notice Node 1 is showing as offline. So when it boots up, it's going to start the Ricky service. Ricky is going to rejoin the cluster node to our cluster. And then because this service is set up as prefer node 1, and node 1 has rejoined the cluster, what I expect to see happen is the service to fail back to node 1. Right? So node 1 just came online. Right? Whoops, right here. And let me take a look over here as well. There we go. So he's shutting down the service on node 3, and then we expect to see that change to a state starting on node 1, which he just did, and then it should resume on node 1. All right, so now he's in state started, which means when I access this IP address, I lose Conquer. I think I lost Conquer. All right, so after I restart my browser, because I'm doing over SSH, and Conquer sometimes gets cranky when running over SSH, but there's my file. And if I look at node 1 again, I'm going to take a look at its IP addresses, and we should notice that the floating IP address has moved from node 3 back to node 1, so I'm waiting for that to connect. Go over here. So before, under ETH1 here, this is where we saw 172.16.1.50. Notice that it has now been removed from this node. There we go. Okay, if we take a look at its IP address, there's my floating IP address that got reassigned between them. All right, so that's deploying a service using Red Hat Cluster Suite. So let me go back over to the Ricky interface. Not a new window. New tab. All right, so here's my cluster. We got all of our nodes, we got their states, and over under service groups, there's our service that's currently running. Now notice in the Lucy web interface, not only can we add services, we can also control the service from here. So if it's not running, we can use start to start it. Restart would shut it down and start it back up again, and disable would stop it and keep it from running. All right, so that's how we control the service. We could also click on this service name, and that'll bring up all the properties of it, so all of our resources that have been added to it. But we can also do things like tell it that we want to start it up on a different node, or at some point in the future, if we've defined a different failover domain, where it should be going to a different node in the event of a failover event, we can change that. So we can edit the service or edit the resources later by using the Lucy Web UI. All right, and we can control the state of the service now using the Lucy Web UI. But remember that Lucy is really just a front end for doing the XML-based configuration file on all the nodes. And it turns out that there are a couple of command line tools that allow us to interact with this service as well. All right, so I already showed you one of the command line tools, cluestat. So that shows us the status of our cluster and all the services that are running on it. And we could take a look at the cluster configuration file. So we have our cluster name, and then we have a section for each of our cluster nodes and its fencing device. And if we scroll down, Here's a segment for our failover domain that's been defined, and our different resources that we've made. And then lastly, the service section. The service section is where we tell it the failover domain, the name, its recovery policy, and then here are the service or the resources that go with it. All right, so this file is what's being built by Lucy. But if we have access to the file, we can also change the file manually. So we could fire up VI and edit this file, and we could change the contents and then push it to all of our cluster nodes to update their configuration. All right, I'm not going to do that, but I will tell you how we would do it. So one of the things that we need to do is this guy. So after we make our manual change, we'd also have to change the version. The version is how the cluster nodes determine whether the version that they have currently is newer or older than the version that's trying to be sent to them through the command line tools. So we'd want to make sure that we increment the version as something bigger than all the other cluster nodes have. All right, then we have this thing called CCS tool. Oops. There we go. It allows me to do things like query the cluster configuration. You can do things like list the fencing devices, add fencing devices, delete fencing devices. You can add and delete nodes using this tool. So this tool is really working with that XML configuration file again, but it's not web-based, it's instead command line based. And then we also have CCS. Let's try this guy. No. I want to say it's another option to CCS tool. We can take our configuration file and we can copy it to the other nodes. I'm sorry, it's escaping my memory at the moment. All right, one of the other command line tools that we have to control services is Clue Service ADM. All right, Clue Service ADM would allow us to do things like enable a service if it was disabled, right? So that's basically using the start functionality in Lucy. We can relocate a service to another node, so we can actually push it somewhere else. We can, where is disable? There it is, disable a service. So we can turn the service off. So if I wanted to disable the Webby service, and let me bring up a watch over here, then when I tell it to disable, it's stopping the service, which means that when we try to access its IP address, right, it's spinning. It's not able to connect to this IP address anymore. Notice that the thing here is highlighted in yellow. Because I've disabled it, when I stop the service, I take away the floating IP, I take away the file system contents, I stop the Apache daemon. And if I look over here in my clue stat, right, set is disabled. If I go over to Lucy and look at my service groups, he's also changed the status disabled. So if I clicked this disable button in Lucy, that would have done it. But I used Clue Service ADM to control it. And then we can also enable it again or start it back up again. So enabling starts it up. It's just like coming over here to the Lucy interface and telling it to start the service. All right, if we look at our clue stat, it's been started back up again. If I connect to its floating IP address, we're able to access our shared web page again. All right, so we talked some about cluster.conf. There's just an XML file. If you really wanted to, you could manually edit it, or you can use the CCS tool command line utility for making changes to it and propagating it to your other nodes. We talked about some of the command line tools that go with Cluster Suite. So ClueStat to get the status of the service. Clue Service ADM, which is CLU SVC ADM to enable, disable, relocate, and control the services that are running through Cluster Suite, and then CCS tool, which we can use for modifying the cluster configuration. All right, so questions. I'm going to turn off my desktop sharing, and I'm going to go over to the question and answer portion. All right, so one of the questions is, so the host running Lucy is the master node and does not have to be a cluster member. And the answer provided by Vonder, a host running Lucy should never be a member of the cluster, but one Lucy node can control multiple clusters. Right? You don't want Lucy to be a member of the cluster, or I should say doesn't have to be a member of the cluster. If you lose your Lucy node, your cluster will still operate correctly, right? They all have a copy of their cluster.conf file. You can use the command line tools on the cluster nodes to manipulate the services and the contents of your cluster.conf. Lucy is just a web UI for interacting with the Ricky daemons running on all of the cluster nodes, and for providing you a web UI for defining what should go in the cluster.conf file. All right, somebody else asked if each of the nodes was a RHEL server. Yes, it is a RHEL server. For this, we're using Red Hat Enterprise Linux 6, and then the cluster suite, which includes Conga, which is the Lucy and Ricky daemons. That's the high availability add-on that you can purchase in addition to your RHEL subscription. All right, somebody asked if the machines were SCSI-connected storage nodes. Our machines are regular RHEL 6 servers, although they're running in a virtual, they're running as virtual machines. In our setup, I used iSCSI to present a shared device, a shared SCSI device to all the nodes, so I can make sure that when somebody failed, that we could pass over, when somebody failed, we could pass over control of that device to another cluster node. Right? I want to make sure that the same content got presented multiple places. All right, somebody else asked if each cluster node needs their own fenced device. You want to have each cluster node with a fenced device, right? It has to have a way of being removed from the cluster. Now, they don't all have to use the same fenced device. So if we mixed our architecture a little bit, maybe I was running physical machines and virtual machines as part of our cluster, then I want to use a virtual machine fencing device for the virtual machines, and maybe ILO, DRAC, SSH-enabled power supply, some type of method for fencing off the physical boxes as well. And I can mix the nodes in the same cluster, but I want to make sure that there's a fenced device for each node that's appropriate for that node. All right, somebody else asked how many high availability add-on subscriptions one would need to create a 3-node cluster. So you need a high availability add-on subscription for every node within the cluster, and for the machine that's running Lucy if you would like to run Lucy. All right, somebody also asked if you can handle load balancing in the failover domain. No, as part of the high availability add-on, there's a separate load balancing offering based off of, I believe, the open source project LVS, Linux. I don't remember what it stands for anymore. But that is not the same as the Conga suite that we've been talking about here. It's different. Right, is the priority domain applied to a resource group level or across the entire cluster? And Vonder replies, a failover domain is defined across the cluster. So any resource group, any service you define can be configured to use that failover domain. All right, somebody asks if the flapping around of services gets logged somewhere central and or on each node. It gets logged on each node. So over here, let's go to my node. Any cluster-related content that happens on this node is sent to varlog messages. So we can see the content of our log messages here of it starting and stopping different services. And then in var log, what is it? Oh, you know what? I wasn't sharing my screen. Hold on for just a second. All right, let me start up my screen share again. 1 minute. All right, so over here on node 1, any services that are being executed specifically by node 1 get logged into its var log messages. All right, so here we can see, the service isn't running, that it started it up, and that it's now running the Webby service. And then all the nodes get the same content stored in a log in var log cluster RG manager. So this should be the same across all of the nodes. Shouldn't say that. Services will, or cluster transactions will be logged into this file across the nodes, assuming that they're part of the cluster and that they're healthy and they're able to communicate with the cluster. Right, so down here at the bottom, here's the starting up of this service. All right, somebody asks how to manage the cluster if Lucy goes down. You don't need Lucy. You can do things with the CCS tool. There's another cluster tool that I didn't mention called CMan tool. That's the one that we used for propagating the cluster config. You can edit the cluster.conf directly and push it out to all your other nodes. So really the Lucy node is just providing that web-based front end, but you don't need it, right? All of the stuff that gets generated by that web-based front end is put down on each of the individual nodes running Ricky. All right, somebody asks how we should back up the cluster, and Vonda responds the same way you would back up a regular machine. You want to back up your shared storage separately from the actual nodes. You probably want to back up your cluster configuration file, at least a copy of them somewhere. Somebody asks, what happens when a cluster of 2 nodes, so we're talking about a 2-node cluster, loses the network connection between the 2 nodes? Well, that can be really bad. 2-node clusters are, while they are supported by Red Hat support, 2-node clusters bring some interesting challenges. One of them is if the 2 different nodes don't recognize that they don't have a view of what's properly going on in the cluster. So if that occurs, you get a situation known as split brain, where each cluster node thinks it's the master of the cluster, and they end up smashing each other over and over again. Typically what will happen is, like with our fencing model, where I'm using a power-based fencing, the 2 nodes cast their vote, and whoever gets the first vote wins the quorum election and kills off the other node by making a fence request to the hypervisor. So that node reboots. If it comes back and the cluster still doesn't behave properly, then the 2 nodes cast their vote again, and whoever casts the first vote, the one that actually occurs first, wins, and he sends a fence request off to the hypervisor who kills that node. And it could be the case that after each node reboots and it comes back, that the cluster is still not able to communicate between itself, and they'll just constantly reboot each other. Whoever votes first will reboot the other one, and there's no guaranteeing that the same node is always going to win. So 2-node clusters bring some interesting challenges. There are some things that you can do to try and avoid that, but a 3-node cluster is a better solution. All right, is there an option to freeze the cluster from the web interface? I don't know what you mean by freeze. Somebody asked in the VMware environment, which are all fence can be used? There is a VMware fence agent. I believe it's tech preview only. I've not had any personal experience with it. So there is an option there that one might use. I have no experience using it. And if it's marked as tech preview, that means that it's not supported by Red Hat technical support. Somebody asked if we have a debug mode in the high availability add-on to just bring up the resources. Resources don't get activated until the service that ties them all together gets turned on. But what you can do is look at the log when you activate a service, and it will tell you which of the resources are having problems. Once you figure out which resource has problems, then you can look for resolving that. So for example, yesterday I was doing a dry run of setting up my cluster and starting up my service and failing it all over. And it turns out that I did not have the SE Linux context on my file system set correctly. So when the Apache daemon would start, it would try to access the var www HTML location, and SE Linux would prevent it, which would stop Apache from running, or I should say would cause Apache to fail to run. So, I basically mounted the file system there myself and started up Apache and then looked at different places that Apache would log to try and figure out what problem it was having with it. I could see in the logs from starting the service that the IP address was assigned successfully, that the file system was mounted successfully, and then it was the Apache assign or Apache service starting is the thing that was failing. So that allowed me to narrow my troubleshooting to a specific service. All right, somebody asked if the cluster service is MySQL and a node fails, will there be a delay when the database comes back up and recovers itself on another node? Absolutely, because what happens is the cluster has to recognize that the node running that service has failed. Excuse me for one more second. Sorry about that. So the cluster has to recognize the node has failed, and then the service will stop on that node to try and release all the resources, or at least get the resources to a known state. Then it has to move over to the new node and start back up again. So all those steps take time, and during that time, whatever the service is going to be inaccessible from the outside world. Now, how long it takes? Well, that depends. You can see that with the Apache service, it was very quick, a couple of seconds. But my machines all have a pretty speedy network connection to each other. The service itself is not very complicated, so it was able to start up and stop very quickly. For something that takes longer, well, then your failover is going to take longer. All right, somebody asked what type of limitations for the services can be clustered with the high availability add-on. And Bonder responds, in general, you can cluster any service with the high availability add-on. If there's not a specific resource, you can use the script resource to define an init script of your own or write your own resource agents for that service. All right, somebody asked if we can use cluster services for active-active load balancing. The Conga suite, Lucy and Ricky daemons, are for doing active-passive. Right, so we have one node running our service, and if it fails, then it gets passed to somebody else to start up the service. If you want to do active-active, really what you're wanting to do is load balancing. There's another portion of the high availability add-on that does load balancing specifically, where it has a couple of routers that sit in the front of your cluster. The back end of your cluster is a whole bunch of identical nodes that offer the same service and same data, so that the connection comes into the load balancers, they farm it out to one of the back-end working machines, and then the back-end working machine provides the answer for the client that's requested it. So it's not part of the high availability add-on that we've been talking here. All right, it looks like we're about out of time. I'm sorry that I wasn't able to get to all of your questions. But as a reminder, this is a portion of the Red Hat training course RH436. Here we go. It's a portion of the Red Hat Clustering and Storage Management course, RH436, and there's the URL for you to find the description and other things. Basically what we talked about in terms of defining a service and starting it up is a couple hours of one day. But there's a ton of other stuff in this class. So I set up multipathing and iSCSI targets. Well, that's in this class. We had to do all the infrastructure setup, the failover domain, the fencing setup. One of the things we didn't talk about was quorum. That's something that's covered in the class. So, and there are other examples of services. We not only set up the web server, but we also set up a highly available NFS share. We also talk about some other file system types. So ext4 is probably not the best because it doesn't have any cluster file locking. So I was able to access the same file from different nodes, and there would be no guarantee that that file wouldn't be clobbered by the other nodes. So we covered GFS in this course as well, so that you can actually use a cluster-aware file system. So a lot of good stuff. What we covered, the setup stuff that I did was about a day and a half of the course, and then the actual deploying of the service, there are a couple of those that occur, which is about another half day. All right, well, thank you for attending. I'm going to go ahead and put a pin in it. Again, I'm sorry that I wasn't able to get to all of your questions, but I appreciate your time and your attentiveness in our session.